So using the knowledge we were working on, let's try to sketch a graph of f of x equals negative 2, x plus 3 to the power of 2, x minus 5. So just by looking at this, let's find my short run behavior, meaning I'm going to find my x-intercept and my y-intercept. So now right here, my x-intercept is when y is equal to 0. So I'm going to set this equal to 0. X plus 3 squared, x minus 5. So now right here, I know that x is equal to negative 3 and x is equal to 5. Now also for my short run behavior, I need to know how my graph is going to behave around these x-intercepts. So notice right here at x equals negative 3, I have a power of 2. Since this is a power of 2, I know I'm going to have a multiplicity of 2, meaning that around this x-intercept, my function is going to look like a parabola. And x equals 5, it's going to have a multiplicity of 1 because the power of this factor is 1, meaning that this x equals 1, my graph is going to behave as a linear function. So now with that, when I have these two, now I need to find my y-intercept, and that's when x is equal to 0. So I set my function for every x I input is 0. Negative 2, 0 plus 3 squared, 0 minus 5, negative 2 times 3 squared, times negative 5, negative 2 times 9 times negative 5, and it equal to 10 times 9, which is equal to 90. So I have my y-intercept at 90. And now I know that right here, my a is equal to negative 2. Right here, I need to know my leading power, my leading term power. And in order to find my leading term power, I can expand my equation, or I can just take the power of each of my factors, adding them together, and that's gonna give me my leading term coefficient. So right here, I know that my n is gonna equal to 2 plus 1, which is 3. So I know that my graph is gonna behave for the long-term behavior. It's gonna have the behavior of an odd function. So, but since right here my a is a negative number, I know that my function is gonna look like this. And right here, I know that the behavior of this function, it's gonna be as as x goes to positive infinity, f of x is gonna go to negative infinity, and as x goes to negative infinity, f of x is gonna go to positive infinity. So now let's try to graph my function. So I know that I have my x-intercepts at x equals negative 3. So right here. And I know my other x-intercept is gonna be at x equals 5. So now let's draw my graph. So at x equals negative 3, I know that I have a multiplicity of 2, meaning my graph is gonna have a parabola shape. So right here, and I know that my end behavior, so as x goes to negative infinity, my graph is gonna go to positive infinity, meaning that my graph is gonna start at the positive values. At x equals negative 3, I know I'm gonna have a parabola shape. So I know that my graph is gonna go up. Now at x equals 5, I need to consider my long-term behavior as x approaches positive infinity. I know that my graph is gonna go downward. So right here around x equals 5, I know that my graph is gonna look like this. So now right here, I don't have any other x-intercepts, but I know that I have a y-intercept at 90. So right here, my graph is short. I'm not gonna have an accurate graph. However, I'm gonna just pretend that 90 is somewhere around here. And your graph is gonna look something like this. to get an accurate graph, you can use decimals to look at it. But a rough draft of my graph, I know that it's going to look something like this. So my graph is going to look something like